In this video, we are going to explore some of the greatest deep space anomalies. Don't worry, guys. I will try to explain in a very simple, calm, and easy to understand way. If you are a space enthusiast like me, you are in the right place. I hope you will learn something new from this video. The laws of physics are supposed to be perfect, but right now the universe is breaking them. We have found stars that fake their own deaths, signals that hide when we look at them, and a gravitational monster pulling our entire galaxy toward a destination we cannot see. These aren't just random glitches. They are cracks in the windshield of reality. We are the first generation with the eyes to see them, and ignoring them is no longer an option. We are about to zoom out from our solar system to the very edge of the simulation to find the truth. Let's see what's hiding in the dark. Chapter 1: The Three-Eye Atlas Mystery. For 8 years, we told ourselves a comforting lie. We looked at the data from 2017, we looked at the strange cigar-shaped object that tumbled past our sun, and we told ourselves it was just a rock. Weird, yes. Rare, absolutely, but natural. We called it Oumuamua, a visitor from afar, and when it disappeared into the dark, we convinced ourselves that we would never see anything like it again. We thought it was a one-time event. We thought our solar system was lonely, empty, and predictable. But we were wrong. Because in late 2025, just a few weeks ago, the alarm bells at the Atlas Observatory in Hawaii started ringing again. And this time, the data isn't just weird, it is impossible. The universe is usually silent, but sometimes it whispers. And right now, it is screaming. Astronomers have just confirmed the entry of a new object into our solar system. They are calling it Three-Eye Atlas. The eye stands for interstellar. It means it is not from here. It wasn't born from the dust of our sun. It travelled light years through the freezing void to get here. And unlike the first visitor, which we only saw on its way out, we have caught this one on its way in. But the excitement of the discovery vanished the moment the first telemetry readings came back. The mood in the control rooms turned from curiosity to pure fear. Why? Because rocks don't behave like this. Let's talk about how a normal object moves in space. Whether it is a comet, an asteroid, or a planet, everything follows the same master: gravity. Isaac Newton wrote the rules 300 years ago, and everything in the sky obeys them. When a rock falls toward the sun, it speeds up. When it moves away, it slows down. It follows a smooth, predictable curve. You can calculate exactly where it will be in 10 years or 10,000 years. It is clockwork. But Three-Eye Atlas is not following the clock. When the Atlas telescope first picked up the glint of sunlight reflecting off this object, the computers immediately tried to calculate its orbit. But the math broke. The object was moving at a speed that shouldn't be possible for a natural rock falling into our system. It was clocking in at over 90 kilometers per second, way above the speed limit of our sun's gravity. This means it isn't just falling, it is driving. It has so much energy that the sun cannot hold it. It is punching a hole straight through our neighborhood, but speed alone isn't proof of aliens. We have seen fast rocks before. The terror started when we looked at the direction. As 3I Atlas approached the inner solar system, passing the orbit of Mars, it did something that made astrophysicists spill their coffee. It changed course. And I don't mean it drifted slightly because of gas venting or solar wind. I mean it turned. Imagine you are watching a car roll down a hill. It's moving fast, powered only by gravity. Suddenly, without hitting anything, the car banks left and accelerates. That is impossible unless the car has an engine. That is exactly what this object did. It experienced what scientists call non-gravitational acceleration. With Oumuamua in 2017, skeptics argued that maybe it was a comet venting invisible gas, pushing it like a rocket. It was a stretch, but it was a comforting explanation. It allowed us to sleep at night. But 3I Atlas has stripped away that safety blanket. We have pointed our most powerful infrared telescopes at it, looking for heat, looking for gas, looking for a tail. There is nothing. It is dead silent. It is not a comet. There is no gas jet pushing it. So what pushed it? What gave it the energy to pivot against the pull of the sun? The only explanation left is one that terrified the scientific community: radiation pressure. Or, as you might know it better, a solar sail. The math suggests that 3I Atlas is incredibly thin, thinner than a sheet of paper, but massive in surface area. It seems to be catching the light of the sun like a ship catches wind, using the photons to steer itself. Nature does not build flat, perfect sheets of material. Nature builds lumps. Nature builds potatoes. Nature does not build sails. If this object is harnessing the power of our star to navigate, then it is not a rock. It is a machine. And then we analyze the light bouncing off its surface. This is where the mystery turns into a nightmare. Usually, asteroids are dirty. They are covered in carbon, dust and ice. They reflect very little light. They look like charcoal. 3I Atlas is different. It is shiny. The spectral analysis returned a composition that shouldn't exist in the vacuum of space, nearly pure nickel and iron. To get pure nickel, you need a smelter. You need to separate the ore from the rock. You need extreme heat and industrial processing. You need a factory. We have never ever found a natural asteroid made of refined metal. This suggests that the object isn't just a visitor. It is a hull. It is artificial plating. It is a shield. We are looking at something that was built, forged in the fires of a civilization we have never met, and sent across the dark ocean of space to find us. This brings us to the most chilling question of all. Why? Why is it here? Oumuamua was a scout. It flew past us, took a look, and left. Now, 8 years later, a second one arrives. But this one is different. It adjusted its course. It decided to get a closer look at Earth than the previous trajectory allowed. Is it transmitting data? Is it sending a map of our defenses back to a home world? Or is it a derelict, a piece of space junk from a dead civilization drifting forever through the void? We want to believe it's just a rock. We want to believe the data is wrong. But the object is getting closer, and the anomalies are piling up. It has no tail. It moves too fast. It turns without an engine. It is made of refined metal. At a certain point, skepticism stops being scientific and starts being denial. We are standing on the beach, watching a ship sail into our harbour, and we are still arguing about whether or not wood floats. The universe has knocked on our door twice now. The first time we ignored it. This time we cannot look away. This is the reality of 2025. The sky is no longer empty. The silence has been broken. We are not alone, and we are not the ones in charge. 3i Atlas is proof that the galaxy is busy, and we are just the ants living in the driveway. But while we stare up at this shiny metal phantom racing through the stars, terrified of what it implies, we are missing the bigger picture. We are so focused on the stranger passing through our town that we have forgotten to check the basement. Because if an interstellar probe can enter our solar system, perform a maneuver, and watch us, what makes you think it's the only one? What if the others aren't just passing through? What if the others stopped? What if they have been here for millions of years, waiting, watching, and hiding in the dark corners of our own solar system? The visitor is scary, yes, but if that's just passing through, what about the things hiding inside our own home? Chapter 2. The Chino Object. We grow up looking at maps of our solar system that are neat, tidy, and finished. You learn them in school. The sun is in the middle, then the 4 rocky planets, then the asteroid belt, and finally the gas giants. We think of our celestial neighborhood as a well-lit room where everything has been found, catalogued and named. We assume that if something big was floating around out there, we would have seen it by now. We assume the map is done, but that arrogance is our biggest blind spot. The truth is, the map is mostly empty space, and in that darkness, things are hiding. We just turned on the flashlight in the space between Saturn and Uranus, a frozen no-man's land where nothing interesting is supposed to happen, and we found a ghost. This isn't a story about a planet, and it isn't a story about a comet. It is a story about a glitch in the laws of physics. Meet Chino. For decades, astronomers have ignored the Centaur region. This is the dark, cold gap between the orbits of Jupiter and Neptune. It is a graveyard for icy rocks that don't quite fit in. They are too small to be planets, too big to be comets, and unstable. We usually just track them and move on, but in early 2025, a deep space survey flagged an object officially catalogued as a minor planet, but nicknamed Chino by the team that found it. At first glance, Chino looks like nothing. It is a lump of ice and charcoal about 100 miles wide, spinning silently in the dark. It looks dead. But when we watched it pass in front of a distant star, the light didn't just vanish. It flickered. This is a technique called occultation. It is how we find rings around distant planets. If a rock is just a rock, the star behind it disappears for a second and then reappears. Blink, gone, back. Simple. But with Chino, the star winked out, then flickered, then went dark, then flickered again before reappearing. That pattern, that heartbeat of light, means only one thing. Chino isn't alone. It is surrounded by a ring system. Now, pause. You need to understand why this is impossible. Rings are for giants. Saturn has rings because it is massive. Its gravity is strong enough to rip moons apart and spread their dust into a beautiful flat disk. Jupiter, Uranus and Neptune have rings for the same reason. Small rocks like Chino do not have the gravity to hold onto a ring system. It's like finding a grain of sand holding onto its own personal atmosphere. It shouldn't happen. But nature loves to break rules, so we accepted it. We thought, okay, maybe it smashed into another rock recently and this is the debris. But then we got a better look, and the confusion turned into obsession. The ring around Chino is wrong. A natural ring, left alone, will eventually smooth itself out. Gravity loves symmetry. Over time, particles bump into each other, energy is lost, and the ring becomes a perfect flat circle. It becomes uniform. Think of Saturn's rings, smooth, continuous loops. But the ring around Chino is broken. It is lopsided. It is thick and dense on one side and thin and wispy on the other. It looks less like a ring and more like a horseshoe or a broken bracelet. This is where the physics starts to scream at us. A lopsided ring is unstable. According to every simulation we have run, the particles in the dense part of the ring should be crashing into each other. They should be spreading out. Within a few years, or maybe a few decades at most, this ring should have dissolved into a uniform haze or crashed onto the surface of Chino. It is scientifically impossible for a ring to stay clumped like that without help. Yet, looking at the age of the dust, we know this ring hasn't been there for years. It has been there for millions of years. So we have a structure that should be falling apart, but it is staying together. It is frozen in a state of collapse, refusing to die. How? In astronomy, when we see a ring that is sharp, defined, or lopsided, we usually look for a shepherd. A shepherd moon is a small moon that orbits right next to the ring. Its gravity acts like a sheepdog. If a dust particle tries to drift away, the shepherd moon pushes it back into line. Saturn has them. Uranus has them. It is the only way to keep a ring looking sharp. So naturally, we looked for Chino's shepherd. We scoured the data. We ran the calculations. We looked for the gravitational wobble of a moon hiding in the glare. We found nothing. There is no moon. There is no shepherd. There is no sheepdog guarding this flock. So what is holding the ring together? What invisible force is grabbing these millions of tons of rock and ice and forcing them to stay in a broken, unnatural shape against the will of gravity? This brings us to the most unsettling theory, the magnetic trap. Chino is too small to have a molten core, which means it shouldn't have a magnetic field. Earth has a magnetic field because we have a churning ocean of liquid iron in our center. Chino is a frozen ice ball. It should be magnetically dead. But the way that ring is behaving mimics the way plasma behaves in a magnetic containment field. It looks like the particles are being held in place not by gravity, but by an unseen charge. If Chino has a magnetic field strong enough to shape solid matter, it means the inside of this object is not what we think it is. It means the core is active, or it means the ring itself is conductive. Some astronomers have quietly suggested that the dust in the ring might not be rock at all. If the material contains high amounts of metallic anomalies, similar to the ones found in the 3I Atlas object we just talked about, it could interact with the solar wind to create a self-sustaining electromagnetic lock. Imagine that? A ring of metal dust charging itself up in the solar wind, locking itself into a rigid shape that defies gravity. That is not how asteroids work. That is how machines work. We are looking at an object that appears to be a natural rock, but it has accessories that defy natural explanation. It's like walking through a forest and finding a tree that is wearing a wristwatch. The tree looks natural, but the watch tells you that something else has been here. Chino is that tree. The ring is that watch. The broken ring suggests that something happened here. A violence, a disruption, or perhaps a purpose. Why is the material clumped on one side? Is it a shield? Is it a counterweight? We don't know. All we know is that our models of dead space are failing. We used to think that unless a planet was huge, it was boring. We thought asteroids were just debris left over from the construction site of the solar system. But Chino is proving that the debris is still alive. And here is the part that keeps scientists awake at night. We only found Chino because we got lucky. We only saw the ring because it happened to pass in front of a star at the exact right second. How many other Chinos are out there? How many other objects are floating in the dark between Saturn and Uranus, carrying impossible geometries, broken rings, and magnetic anomalies that we simply haven't seen yet? We are realizing that our backyard is not empty. It is cluttered with things that don't make sense. We are realizing that gravity isn't the only boss in town. There are other forces, magnetic, electrical, or perhaps something we haven't named yet, that are sculpting our solar system. Chino is a ghost because it shouldn't exist. It is a structure that should have faded away eons ago, yet it remains, turning silently in the dark, mocking our understanding of orbital mechanics. If a simple rock can hold on to a broken ring for 1,000,000 years without a moon to help it, then we don't understand gravity as well as we thought we did. And if we don't understand gravity, then we don't understand the universe. Chino is a small mystery, yes. It's just a rock. But it is a loose thread. And if you pull on a loose thread hard enough, the whole sweater unravels. We have found the visitor from the stars, 3I Atlas. We have found the ghost in the backyard, Chino. We are seeing things that shouldn't be there. But visual anomalies are one thing. You can stare at a photo and argue about pixels. You can debate the composition of a rock. But sound is different. Sound is immediate. Sound is intentional. And while we are busy staring at rocks and rings, trying to make sense of the visual evidence, we have ignored the fact that the universe isn't just showing us things, it is speaking to us. While we look at rocks, something else is screaming at us from the dark. Chapter 3. The Heartbeat Signal. If you go to the quietest place on Earth, maybe a deep cave or an empty desert, and you hold your breath, you think you're experiencing silence. You aren't. Even in the quietest room, there is the hum of electricity, the wind outside, or the thumping of your own blood. We don't know what true silence is. To find that, you have to leave the planet. You have to go to the void between the stars. Space is a vacuum. Sound waves cannot travel there. By all logical definitions, the universe should be a tomb. It should be dead silent. But we have built ears that are better than our own. We have built giant radio telescopes, massive metal dishes the size of football fields that point at the sky and listen to the electromagnetic whispers of the cosmos. And for decades, all we heard was static. We heard the low, boring hiss of the background radiation left over from the Big Bang. It was the sound of an empty room. But recently, the room stopped being empty. Someone or something started screaming. We need to talk about fast radio bursts, or FRBs. If you take nothing else away from this video, remember this. An FRB is the most violent, energetic, and terrifying event in the known universe, and we have absolutely no idea what causes them. Imagine the sun. It is a giant nuclear bomb that has been exploding for billions of years. It provides all the energy for life on Earth. Now, imagine taking all the energy the sun produces in a century. Every single photon, every bit of heat, every solar flare for 100 years, and compressing it into a single millisecond. 1 millisecond. That is an FRB. It is a flashbulb pop of energy so bright and so loud that it crosses billions of light years of empty space to smack into our telescopes. When we first found them in 2007, we thought they were glitches. We thought someone had opened a microwave oven in the observatory break room. The power was too high. The duration was too short. Nature doesn't usually scream like that. Nature rumbles, nature burns, but nature does not snap. But then we found another one, and another. We realized that these weren't glitches. They were coming from deep space, from galaxies far outside our own. Something out there is detonating with enough force to wipe out entire solar systems in the blink of an eye, and we are just lucky enough to be far away, hearing the echo. For years, the scariest thing about FRBs was that they were random. They were like lightning strikes in the dark. One would pop off in the northern sky, then silence. Another in the south, then silence. They were transients, one-off events. This led to the theory that they were cataclysms. Maybe two neutron stars crashing into each other, maybe a black hole eating a star. Events that happen once, destroy everything involved, and never happen again. That theory was comforting. It meant the universe was chaotic but simple. Things break, they make a noise, they die. But then the signal changed. We found the repeater. It started with a signal named FRB 121102. Unlike the others, this one didn't just scream once and die. It kept screaming, bam, bam, bam. It hit us over and over again. This killed the cataclysm theory immediately. You can't die twice. Two stars can't crash into each other, explode, and then do it again next week. Whatever is generating this power survived the explosion. It is a gun that reloads. This shifted the conversation from accidents to engines. Is it a magnetar? A star with a magnetic field so strong it twists atoms into needles? Maybe. But then we found something even stranger. We found the heartbeat. In 2020, astronomers analyzing a signal called FRB 180916 noticed a pattern buried in the noise. This wasn't just random repeating, it was a schedule. The signal would fire actively for 4 days, blasting us with energy, and then it would go silent for 12 days. Then, exactly on time, it would start again. 4 days on, 12 days off. A perfect 16-day cycle, like a clock, like a metronome, like a beacon. Nature hates perfect clocks. Orbits can be regular, yes, but a burst of energy that keeps a schedule like a train arrival, that is unnerving. It suggests a structure. Maybe the source is orbiting something else and we only hear it when it swings around the corner. Maybe it is a lighthouse beam sweeping across the universe and we only get hit when the light points at Earth. But the precision is what haunts us. It feels mechanical. It feels automated. It feels like a machine left on ping mode, broadcasting a heartbeat into the dark for a civilization that might have died 1,000,000 years ago. But if the heartbeat signal was weird, what happened in 2025 changed the game completely. This is the new discovery that has radio astronomers looking at their screens in disbelief. We found a signal that seems to know we are watching. We call it the shy signal. Earlier this year, the telescopes in China picked up a massive new repeater. It was loud, it was close, and it was active. It was firing bursts every few hours. The astronomical community got excited. This was our chance to study an FRB in real time. We alerted the global network. Every major radio telescope on Earth, from the VLA in New Mexico to the arrays in Australia, swiveled to point at this specific patch of sky. We were ready to catch it in high definition. We turned on the recording equipment, we waited, and silence. The moment we focused our collective attention on it, the signal stopped. It didn't just fade, it cut out completely. It was as if someone flipped a switch. For 3 days we stared at that spot, nothing. Just background static. The scientists were baffled. They assumed the object had just gone dormant naturally. It happens. Bad timing, right? So, eventually, the big telescopes had to move on. They had other projects. One by one, they turned away to look at other stars. And the exact second, we stopped looking, the signal came back. A small, automated monitoring dish, a low-priority instrument that was still passively listening, caught it. The moment the main observatories looked away, the sky at that location lit up again. Bam, bam, bam. The source was screaming again. So the astronomers scrambled. They turned the big dishes back. "We caught you now," they thought. They pointed the high-power receivers back at the source. Silence. It happened again. When we looked, it hid. When we looked away, it spoke. Now, let's be very clear. In quantum physics, there's a concept called the observer effect, where measuring a particle changes its behavior. But that applies to subatomic particles, not giant astrophysical objects the size of cities. A star shouldn't care if we're looking at it. A black hole doesn't get stage fright. A natural phenomenon does not know what a telescope is. There are only two explanations, and neither is comforting. Explanation 1, it is a cosmic coincidence of epic proportions. The timing just happened to line up perfectly with our observation schedule twice. The odds of this are astronomical, but possible. Explanation 2. The signal is not random. It is intelligent. If you were a stealthy spaceship, or a military probe, or a surveillance drone from another world, how would you program it? You would program it to stay quiet when it detects that it is being scanned. You would program it to burst its data home only when the coast is clear. The behavior of this new signal mimics the behavior of a spy. It mimics something that is trying to remain hidden. We are trying to explain this with magnetars and plasma lenses because the alternative is too heavy to handle. The alternative is that the silence of space isn't empty. It is disciplined. It is the silence of a hunter holding its breath. We are sending our own signals out there. We have been broadcasting radio and TV and radar for 100 years. We are the loud neighbor in a dark forest. And now we have found something that screams, keeps time like a clock, and goes quiet when we turn our flashlight on it. We are dealing with energies that can vaporize planets, operating on schedules we don't understand, exhibiting behaviors that look suspiciously like evasion. We used to worry that we were alone in the universe. Now the worry is shifting. The worry is that we are being pinged, scanned, and avoided. The radio waves are telling us that the universe is alive and it is hiding something. But sound is just one sense. We can turn off the radio, we can take off the headphones, we can ignore the screams, but you can't ignore what you see with your own eyes. Audio anomalies are scary because they are abstract, but visual anomalies, those are undeniable. Signals are scary, but a star that vanishes is terrifying. Chapter 4. The Winking Star. There is one thing in the universe that we take for granted above all else: the consistency of stars. Our entire existence, our biology, our history and our future rely on a simple fact. The sun shines. It does not flicker. It does not turn off. It does not blink. A star is a massive ball of nuclear fusion, a furnace so heavy and so hot that it burns with a steady, unyielding light for billions of years. If our sun were to dim by just a few % for a few days, Earth would freeze, crops would die, and civilization would collapse. We trust the stars because they are boring. They are reliable light bulbs that never burn out. But in the constellation of Cygnus, about 1,400 light-years away from where you are sitting right now, there is a star that is breaking that trust. It is violating the contract of the cosmos. It is doing the one thing a star is never ever supposed to do. It is winking at us. This is the story of KIC 8462852, better known as Tabby's star. And it is the single most frustrating mystery in modern astrophysics because it forces us to choose between two impossibilities. Either our understanding of stars is fundamentally broken, or we have finally found evidence of someone else at work. Let's go back to how we found it. We didn't find Tabby's star by looking for aliens. We found it by looking for planets. The Kepler Space Telescope spent years staring at a patch of sky, monitoring the brightness of over 150,000 stars simultaneously. It was looking for transits. A transit is what happens when a planet passes in front of its star. Imagine a moth flying in front of a spotlight. The light dims by a tiny fraction. When Jupiter, the biggest planet in our solar system, passes in front of the Sun, it blocks about 1% of the light. That is a huge transit. 1% is a giant shadow. Most planets block 0.01%. The computers analyzing the Kepler data were bored. They were seeing tiny dips confirming planets and moving on. But when they got to KIC 8462852, the data looked like a glitch. The light didn't dip by 1%, it didn't dip by 2%. In 2011, the light from Tabby's star plunged by 15%. A few years later, it crashed again, blocking out 22% of the star's light. Let that sink in. 22%. There is no planet in the universe big enough to block 20% of a star. Even if you took a planet the size of Jupiter and inflated it until it popped, it wouldn't cast a shadow that big. If a planet that big existed, it would be a star itself. So the astronomers knew immediately, this is not a planet. It is something else. It is something massive. It is something sprawling. And it is something irregular. When a planet orbits, the dip is symmetrical. It goes down, stays flat, and comes up. It's a clean U shape. The dips at Tabby's star are messy. They are jagged. They look like a barcode. This tells us that the object blocking the light isn't a sphere. It is an irregular, chaotic shape. It creates a shadow that shifts and changes. The scientists were baffled. They called these events the dips. They even named them. One dip was called Elsie, another Celeste. They watched as this star dimmed and brightened erratically, with no pattern, no schedule, and no explanation. So the scientific community did what it always does. They tried to find a natural explanation. They were desperate to debunk the mystery. They said, maybe it's a swarm of comets. Imagine 1 billion comets, a giant cloud of ice and rock, smashing apart and creating a massive dust cloud. That would be messy. That would be irregular. That would explain the 22% dip. It seemed like the perfect answer. Everyone relaxed. It's just comets, they said. Mystery solved. But there was a problem that killed the comet theory and brought the terror back. The problem is heat. This is basic physics. If you have a giant cloud of dust and comets blocking a star, that dust is going to get hot. The star's light hits the dust, warms it up, and the dust glows. It glows in the infrared spectrum. If you point an infrared telescope at a dusty star, you should see a massive spike of heat. It is unavoidable. It is the law of thermodynamics. Energy in, energy out. If something is absorbing 20% of a star's light, that energy has to go somewhere. It has to radiate as waste heat. So we pointed our infrared telescopes at Tabby's star. We looked for the heat of the comet swarm. We looked for the glow of the dust. We found nothing. There is no excess heat. There is no infrared glow. The light is being blocked, but there is no hot dust. This is the smoking gun. This is the detail that keeps astronomers up at night. How do you block a massive amount of light without getting hot? How do you create a shadow without creating a glow? The comets are gone. The dust is gone. The planetary collision theory is gone. We have run out of natural explanations. Nature is messy and nature is hot. Whatever is orbiting Tabby's star is cold. This leads us to the narrative that no scientist wants to write, but every screenwriter understands. If it's not a rock and it's not a cloud, what is it? Imagine a civilization millions of years older than us. They don't burn oil, they don't use solar panels on their roofs. They need more energy than a planet can provide. They need the energy of an entire star. So they start a construction project. They begin to build a Dyson swarm. A Dyson swarm is a megastructure. It is a vast network of giant solar collectors, satellites and habitats that orbit a star, capturing its energy. Imagine millions of giant panels, each the size of a continent, floating in space. As they build more panels, they block more light. As the satellites move, they cast jagged, irregular shadows. They aren't hot dust, they are high-efficiency technology. They absorb the energy and beam it away to be used. They capture the light so perfectly that there is very little waste heat. This fits the data perfectly. The 22% dip, that's a cluster of mega-collectors drifting past. The irregularity, that's the complex geometry of the swarm. The lack of heat, that's because the machine is working. It is harvesting the energy, not just absorbing it. The megastructure theory suggests that we are not looking at a natural event. We are looking at a construction site. We are watching a civilization box in their star, panel by panel, turning off the light so they can power their computers, their cities, or their starships. In late 2025, despite years of studying Tabby's star, this theory has refused to die. In fact, it has only gotten stronger. We have found other stars that show similar behavior, dipper stars, suggesting that maybe this isn't a freak accident. Maybe this is what advanced civilizations do. Maybe when you look at the night sky, the stars that you don't see are the ones that have already been conquered. The skeptics are still fighting. They are proposing wild ideas, uneven dust clouds made of cold crystals, or a dissolving moon, or a black hole disk. But every new simulation requires a more complex, unlikely set of circumstances to work. The alien hypothesis is actually the simplest one left. It requires only one assumption, that life exists and it likes energy. This changes how we look at the sky. When you look up, you see points of light. You assume they are wild, untamed fires in the dark. But Tabby's star suggests that some of those lights might be captive. It suggests that on a long enough timeline, life doesn't just live on a planet. It eats the solar system. It turns the nature of the cosmos into a resource. It is a humbling thought. We get excited when we build a dam across a river. We think we are masters of engineering. But 1,400 light-years away, someone might be building a dam around a star. We are playing with blocks while they are moving mountains. The anomaly of the winking star is a mirror. It shows us how small we are. We are looking for a natural explanation because the alternative makes us feel insignificant. We want it to be dust. We want it to be comets. Because if it is a structure, then we are not the big shots of the galaxy. We are the bugs in the walls of a skyscraper, wondering why the lights keep flickering. The universe is full of monsters. Black holes are monsters of gravity. Supernovas are monsters of fire. But Tabby's star is a monster of engineering. It is a sign that intelligence can become a force of nature. It can change the sky. It can dim the suns. But while we worry about stars that are being covered up, hidden behind walls of metal and technology, there is a deeper horror waiting in the data. Tabby's star is scary because it flickers. It suggests something is alive. But in the life cycle of the universe, things are supposed to end. Stars are born, they shine, and they die. That is the rule. That is the cycle. But what happens when that cycle breaks? What happens when you find a star that explodes, dies, and then wakes up? Signals are scary. Megastructures are intimidating. But a star that vanishes is terrifying. And a star that refuses to die? That is a nightmare. If stars can wink out, can they also refuse to die? Chapter 5. The Zombie Star. There is one rule that holds the entire universe together, a rule so fundamental that we never thought to question it. Death is final. In physics, as in life, things have a beginning, a middle, and an end. When a star runs out of fuel, it dies. If it is a small star, like our Sun, it fades away quietly into a white dwarf. But if it is a massive star, a giant, it goes out with a bang. It goes supernova. A supernova is the biggest explosion in the cosmos. It is a violent, catastrophic release of energy that outshines entire galaxies. It is the end of the line. The star rips itself apart, blasting its guts into the void, leaving behind nothing but a cold, dead tomb, a neutron star or a black hole. It is a one-way trip. You cannot unexplode a bomb. You cannot unfire a bullet. And you certainly cannot survive your own funeral. At least that is what we thought. That is what the textbooks say. That is what every astronomer has been taught for 100 years. But in a distant galaxy, 500 million light-years away, there is a star that is breaking the rules of life and death. It is refusing to stay dead. It is the Jason Voorhees of the cosmos. It is the zombie star. To understand why this object, officially named IPTF 14HLs, is so terrifying to scientists, you have to understand the sheer violence of a standard supernova. Imagine the Earth. Now imagine the Earth exploding with enough force to vaporize the entire solar system. That is a sparkler compared to a supernova. When a star collapses, the core implodes at 25% the speed of light. The shock wave hits the outer layers and blows them apart. The star is gone. It is physically impossible for the structure of the star to survive. It is like dropping a glass vase from the Empire State Building. It doesn't just crack, it shatters into dust. So, when the Palomar Transient Factory in San Diego spotted a new explosion in September 2014, nobody panicked. They logged it. They named it IPTF-14HLs. They classified it as a Type 2P supernova. Routine, boring, just another giant star ending its life in the dark. The astronomers expected it to follow the standard script. It would get bright for about 100 days, peak, and then slowly fade into darkness forever. They put it on the dead pile and moved on to the next target. But a few months later, an intern or a graduate student checked the data and they noticed something weird. The star wasn't fading. Usually, after 100 days, a supernova is dimming fast. It's cooling down, but IPTF 14HL's was getting brighter. It was heating up again. The graph didn't look like a slide, it looked like a roller coaster. The star exploded. Then it dimmed. Then it exploded again. Then it dimmed. Then it exploded a third time. Over the course of 3 years, this dead star detonated 5 separate times. The scientific community was stunned. This wasn't just weird, it was impossible. It was like watching a car crash, seeing the car disintegrate into flames, and then watching the same car drive out of the fire, crash again, and explode again. 5 times in a row. A star cannot have enough energy to blow itself apart 5 times. It shouldn't have enough mass left. It shouldn't have a structure left. So the astronomers did what they always do when they are confused. They looked at the history books. They dug into the archives of the Palomar Observatory, looking at photographic plates of that same patch of sky from decades ago. They wanted to see what the star looked like before it died. And that is when the mystery turned into a horror story. They found a photo from 1954. On a grainy black and white image taken 70 years ago, there it was. A bright explosion in the exact same spot. This star had exploded in 1954. It had gone supernova, ripped itself apart, and then it survived. It sat there, wounded and bleeding energy into the dark for 60 years. It healed itself. It gathered its strength. And then, in 2014, it woke up and started screaming again. This discovery sent a shockwave through the astrophysics world. It violates the standard model of stellar evolution. It suggests that massive stars can fake their own deaths. It suggests that a star can survive an event that should vaporize it. We had to invent a new theory just to explain it. The leading theory is something called a pulsational pair instability supernova. Here is the concept, and it is metal as hell. Inside the core of a supermassive star, we're talking 100 times the mass of the Sun, the heat gets so intense that energy starts turning into matter. Specifically, it turns into antimatter. The core starts producing electron-positron pairs. This is a glitch in the star's engine. This antimatter destabilizes the pressure that holds the star up. Gravity wins, the star collapses, but instead of a full collapse, it triggers a thermonuclear explosion in the shell. This explosion blows the outer layers of the star into space. That's the supernova we see. But the core? The core is so heavy and so stubborn that it stays intact. It stabilizes. The star survives the amputation. It settles down, burns for another few years or decades, builds up the pressure again, creates more antimatter, and booms again. It is a star that cannibalizes itself. It is a star that blows off its own skin to survive. It sheds 10% or 20% of its mass in a violent eruption, pretends to die, and then resets the clock. This theory fits the math mostly, but even this antimatter zombie theory has holes. According to our simulations, a pulsational pair instability supernova should eventually kill the star after 1 or 2 pulses. The hydrogen should run out, the energy should dissipate. But IPTF 14H cells kept going. It kept fluctuating for over 600 days in 2014 alone. The amount of energy it released is more than the star should physically possess. It is acting like a perpetual motion machine of destruction. And the scariest part? We don't know if it's done. The star eventually faded in 2017. The light dropped off. We think it finally died. We think the core finally collapsed into a black hole. But we thought that in 1954 too. We thought it was over then. Who is to say it isn't just sleeping? Who is to say that in 2070 or 2080 our grandchildren won't point their telescopes at that same spot and see the zombie star rising from the grave for a third time? This anomaly forces us to confront a terrifying reality. We don't know what happens at the extremes. Our physics works great for normal stars. It works great for normal gravity. But when you get to the monsters, the stars that are 150 times heavier than the Sun, our rules break down. Nature is capable of violence that we cannot comprehend. Think about the implications. If a star can explode and survive, what does that do to the solar systems orbiting it? Imagine living on a planet around a zombie star. You see your sun explode. The sky turns to fire. Your civilization prepares for the end. But the end doesn't come. The fire fades. You survive. You rebuild. A generation passes. You forget the terror. And then it happens again and again. It is a solar system trapped in an eternal cycle of apocalypse. IPTF 40 HRLs is a warning. It is a warning that the universe is not as clean and tidy as we like to pretend. It is messy, it is resilient, and it is capable of creating things that simply refuse to die. It reminds us that impossible is just a word we use when we haven't seen the truth yet. We used to think the Earth was flat. We used to think the sound barrier couldn't be broken. We used to think stars only died once. We were wrong. We are looking at a celestial body that behaves like a horror movie villain. It takes the shot, falls down, and the moment you turn your back, it stands up again with a knife in its hand. It mocks our understanding of permanence. It mocks the concept of game over. But there is a pattern forming here. Have you noticed? The anomalies are getting bigger. We started with a rock, 3I Atlas. We moved to a ring, Chino. Then a signal. Then a single star winking out. Now a star that explodes and survives. The scale is increasing. The stakes are rising. We are zooming out. The zombie star is a localized horror. It is one monster in one specific room of the haunted house. It is terrifying, yes, but it is stuck in its own gravity well. It is an isolated incident. But what if the anomaly wasn't just one star? What if it wasn't just one system? What if the anomaly was happening to everything? Gravity usually pulls things together. It builds stars. It builds galaxies. But gravity is also a leash. And right now, astronomers have noticed that the leash is being pulled by something we cannot see. The zombie star is refusing to die, fighting against its own fate. But out in the deep universe, there is a struggle of a different kind. It isn't about one star surviving. It is about millions of galaxies dying. We are drifting. The Milky Way, Andromeda, and everything around us is being dragged through space at impossible speeds. We are not moving randomly. We are being pulled. We are flowing like water down a drain. And the scary part isn't the speed. The scary part is where we are going. We are heading towards a place where the map stops. We are heading towards a gravitational monster so big that it eats entire galaxy clusters for breakfast. While stars refuse to die, entire galaxies are being dragged to their death. Chapter 6: The Great Attractor. Right now, as you watch this video, you feel stationary. You are sitting in a chair, or lying in bed, or standing on a train. The ground beneath your feet feels solid. The room feels stable. Your senses are telling you that you are at rest. But your senses are lying to you. You are not still. You are moving at speeds that would disintegrate a human body if you weren't protected by the vacuum of space. Let's do the math. The Earth is spinning at 1,000 miles per hour. That's fast. We are orbiting the Sun at 67,000 miles per hour. That is faster. Our solar system is orbiting the center of the Milky Way galaxy at 500,000 miles per hour. That is blindingly fast. But astronomers have found a fourth speed, a speed that doesn't fit the model, a speed that suggests we are being dragged. If you add up all the spinning and orbiting, the numbers should balance out. But they don't. When we look at the cosmic microwave background, the oldest light in the universe, we notice a Doppler shift. The light is slightly hotter in one direction and slightly cooler in the opposite direction. This means we are rushing towards something. We are moving through the universe at a staggering 1.3 million miles per hour. And we aren't alone. The Milky Way, the Andromeda Galaxy, and thousands of other galaxies in our neighborhood are all rushing in the same direction. We are a flock of birds caught in a hurricane. We are being pulled by a gravitational force so massive, so powerful, and so relentless that it is dictating the fate of millions of light years of space. We call this anomaly the Great Attractor. The name sounds like something out of a 1950s science fiction movie. It sounds like a villain, and in a way it is. Gravity is the only force capable of pulling entire galaxies across the void. To generate enough gravity to pull the Milky Way at 1.3 million miles per hour, you need mass. A lot of mass. You need the mass of a quadrillion suns. You need a structure so heavy that it bends the fabric of reality into a deep funnel. So, naturally, we pointed our telescopes at the destination. We wanted to see the face of the monster. We wanted to see what kind of object could possibly be that heavy. We looked at the coordinates in the constellation of Centaurus to see what was pulling us. And we saw nothing. This is the cosmic joke. This is the irony that drives astronomers insane. We can see galaxies 13 billion light-years away at the edge of the visible universe. We can map the afterglow of the Big Bang, but we cannot see the single biggest thing in our own backyard. Why? Because of where we live. The Earth is inside the Milky Way galaxy. The Milky Way is a flat disk filled with gas, dust, stars, and bright nebulae. When we look up at the night sky, we see that beautiful band of white light. That is the disk of our galaxy. It is thick and it is opaque. It blocks visible light perfectly. By a cruel twist of fate, the Great Attractor is located directly behind the thickest part of the Milky Way. It is hiding behind the curtains. Astronomers call this region the zone of avoidance. It is a blind spot in our vision of the universe. It covers about 20% of the sky. We are effectively wearing a blindfold, and something massive is tugging on the rope around our waist, pulling us into that darkness. We know it is there because we can feel the speed. We can measure the acceleration, but we cannot see it. Imagine you are swimming in the ocean. The water is calm. You feel safe. But then you realize you are drifting. The current is getting stronger. You try to swim back, but the pull is too strong. You look ahead to see what is causing the current, but there is a thick wall of fog. You can't see the waterfall. You can't see the drain. You just know that you are moving faster and faster toward the fog, and everything around you, the fish, the boats, the debris, is moving toward it too. That is the sensation of the Great Attractor. For decades, the zone of avoidance kept the secret. But recently, we have developed new eyes. We started using X-ray telescopes and radio telescopes that can punch through the dust of the Milky Way. We started to peel back the curtain, and what we found was not a single object. It wasn't one giant black hole. It was a city of galaxies. We discovered the Norma Cluster. This is a massive swarm of galaxies located right in the heart of the Great Attractor. It is dense, old and heavy. But when we crunched the numbers, the Norma Cluster wasn't heavy enough. It was huge, yes, but it wasn't a quadrillion suns huge. It explained some of the speed, but not all of it. We were still moving too fast. There had to be something else behind it, something bigger. So we looked deeper, peering past the Norma Cluster, deeper into the zone of avoidance. And we found the Shapley supercluster. This is the true monster. The Shapley supercluster is the largest concentration of galaxies in the nearby universe. It is a titan. It holds the mass of tens of thousands of Milky Ways. It is so big that it makes our own galaxy cluster look like a small village compared to a metropolis. This, we think, is the core of the Great Attractor. It is a gravitational basin, a deep valley in space-time. Here is the visual you need to hold in your head. The universe is often described as a flat sheet, but it isn't flat. It is bumpy. Mass creates dips. Stars create little dimples. Black holes create deep punctures. But the Great Attractor? It is a sink. It is a giant drain in the bathtub of the universe. We live in a structure called Laniakea. In the Hawaiian language, Laniakea means immeasurable heaven. It is a supercluster of 100,000 galaxies. And when we mapped Laniakea, we realized it looks like a watershed. Imagine a landscape with hills and valleys. When it rains, the water flows down the hills, joins into streams, then rivers, and finally rushes toward the lowest point. In the cosmos, gravity is the slope. The galaxies are the water, and the Great Attractor is the bottom of the valley. We are currently sliding down the hill, gathering speed, rushing toward this inevitable point of convergence. The scale of this is horrifying. We are talking about a structure that is hundreds of millions of light-years across. It is dragging us, Andromeda and the Virgo cluster, towards a collision that seems inevitable. It challenges our feeling of isolation. We are not floating aimlessly. We are falling. But here is the twist, the final cosmic irony. we will never get there. Despite the terrifying speed of 1.3 million miles per hour, the universe is doing something else. It is expanding, and the expansion is accelerating. Dark energy is pushing the universe apart faster than gravity can pull it together. The space between us and the great attractor is stretching. We are running on a treadmill. We are sprinting toward this monster, trying to fall into its mouth, but the floor is moving backwards faster than we can run. So, in the end, the great attractor is a ghost. It is a destination we are destined to chase forever but never reach. We will spend eternity yearning for this gravitational embrace, rushing toward the darkness behind the Milky Way, only to see it recede into the distance. It will eventually fade away as the universe rips itself apart. We have explored the things that are here: the visitor, Three-Eye Atlas, the ghost, Chino, the zombie star. And now we have explored the thing that is pulling us. The great attractor represents the ultimate power of matter. It is the triumph of stuff. It is what happens when you put too much mass in one place. It screams, "Come here!" It dominates the local universe with its sheer weight. But the universe is a place of balance. For every mountain, there is a valley. For every concentration of mass, there must be an absence. The great attractor scares us because it is too heavy. It is too full. But there is something scarier than a crowded room. There is an empty room. If gravity pulls things together to form clusters and walls and attractors, what happens in the spaces between? What happens when you look at a patch of sky and expect to see the warmth of the Big Bang, but instead you feel a chill? What happens when you find a place with nothing? We are moving from the realm of the heavy to the realm of the hollow. We are leaving the crowded city of Laniakea and stepping into the void. Gravity pulls things together. But what happens when you find a place with nothing? Chapter 7. The Hole in the Universe. If you turn on an old television set, one of those boxy ones from the 90s, and you tune it to a dead channel, you see static. Black and white snow dancing on the screen. About 1% of that static is actually the oldest thing you will ever see. It is the cosmic microwave background, or CMB. It is the afterglow of the Big Bang itself. It is the heat left over from the moment of creation, cooled down over 13.8 billion years, until it is just a faint whisper of microwave radiation. This is the baby picture of our universe. And for cosmologists, this picture is the Holy Grail. It tells us everything we need to know about where we came from. But the most important thing about the CMB is that it is supposed to be boring. It is supposed to be the same everywhere. If you measure the temperature of deep space in one direction, it is 2.7 Kelvin. If you turn 180 degrees and measure the other way, it is 2.7 Kelvin. The universe, at its largest scale, is incredibly smooth. It is uniform. It is consistent. This consistency is the bedrock of the standard model of cosmology. It tells us that the Big Bang happened everywhere at once, spreading energy evenly like butter on toast. There shouldn't be any lumps. There shouldn't be any cold patches. The toast should be perfect. But in 2004, a satellite named WMAP looked at the map, and it found a spot where the butter was missing. It found a spot that wasn't 2.7 Kelvin. It was colder. At first, the scientists laughed it off. They called it a glitch. They said it was a smudge on the lens, or an error in the data processing, or maybe just a random statistical fluke. Nature is random, right? Sometimes you flip a coin and get heads 10 times in a row. They assumed that if they looked again with a better telescope, the spot would disappear. So, in 2013, the European Space Agency launched the Planck satellite. It was the most precise thermometer ever built by human hands. It scanned the sky again with higher resolution, higher sensitivity and better technology. The spot didn't disappear. It got sharper. We call it the cold spot, and it is the single largest anomaly on the map of existence. Located in the southern constellation of Eridanus, this is not just a small fluctuation. It is a behemoth. It is a patch of sky about 70 microkelvins colder than the average. That sounds small to you and me, but in the language of the universe, that is the difference between a tropical island and a glacier. And the size? The size is incomprehensible. The cold spot is roughly 1 billion light-years across. To put that in perspective, our entire Milky Way galaxy is only 100,000 light-years wide. You could fit 10,000 Milky Ways lined up end to end inside this spot. It is a hole in the sky so massive that it dwarfs the largest structures we have ever discovered. And its existence violates the laws of probability. According to our best math, a random cold fluctuation this big should only happen once in every few billion universes. It is statistically impossible. It shouldn't be there. It's like walking into a dense forest and suddenly finding a perfect circular clearing made of glass 10 miles wide. You know instantly that nature didn't do this. So we had to ask the question, why is it cold? What makes a spot in the universe freeze? The answer turned out to be even scarier than the temperature. Temperature in space is usually linked to matter. Where there is stuff, gas, dust, stars, galaxies, there is heat. Where there is nothing, it is cold. So astronomers decided to count the galaxies in the direction of the cold spot. They expected to find a normal distribution. They expected to find the usual web of life. They found a desert. The cold spot coincides with something called the Eridanus supervoid. It is a region of space that is effectively empty. Now, empty in space usually means a few atoms per cubic meter, but this is a supervoid. It is missing 10,000 galaxies that should be there. It is a vast, spherical cavern of nothingness. Imagine you are an astronaut floating in a spaceship. If you are inside the Milky Way, the sky is full of stars. If you are in deep space, you see distant galaxies like diamonds on velvet. But if you were teleported to the center of the Eridanus supervoid and you looked out the window, you would see darkness. The nearest galaxies would be 500 million light-years away, too faint for your eyes to see. You would be floating in an abyss so deep and so black that you would feel truly, utterly alone. It is the loneliest place in creation. But the mystery isn't just that it's empty. The mystery is, how did it get empty? The universe is only 13.8 billion years old. Gravity moves matter around, clumping it into galaxies and clusters, but gravity is slow. It takes time to move mountains. To clear out a space that is 1 billion light-years wide, to shovel all that matter away to the edges, would take longer than the age of the universe. There hasn't been enough time for a void this big to form naturally. It's like finding a 100-foot deep hole in your backyard that appeared overnight. You know gravity didn't dig it. You know erosion didn't dig it. Something took the dirt. We tried to explain it away. We tried to say it was an optical illusion. We tried to say it was a statistical error. But the cold spot refuses to go away. It stares at us from the map, a giant blue bruise on the face of the cosmos. And that word, bruise, might be the key to the whole mystery. Because we have run out of standard explanations, some physicists, like Dr. Laura Mersini-Houghton, have proposed a theory that sounds like science fiction. But the math backs it up. It is the theory of eternal inflation. This theory suggests that our universe is not a unique snowflake. It is a bubble. Imagine a pot of boiling water. Bubbles form, expand, and pop. In this theory, the multiverse is the boiling water. Our universe is just one bubble floating in a foam of other universes. Usually, these bubbles float apart. They expand into the nothingness, never touching each other. We live our lives inside our skin, unaware of the others. But what happens if two bubbles get too close? What happens if they touch? If another universe, a completely different reality with its own laws of physics, bumped into ours during the very early stages of the Big Bang, it would leave a mark. It would be a cosmic car crash. The collision would push matter away from the point of impact. It would scatter the galaxies. It would leave a dent, a scar, a massive spherical region where the density is lower and the temperature is colder. The cold spot fits the profile of a collision signature. Think about the horror of that implication. If this theory is true, then the cold spot isn't just an empty room. It is a window. It is the place where our reality slammed against another reality. It is a bruise left over from a violent embrace with a neighbor we cannot see. We are looking at the fingerprint of a parallel universe. It challenges everything we think we know about being alone. We used to wonder if there was life on other planets. Now we have to wonder if there is life in other universes. And if we collided once, could we collide again? This theory polarizes the scientific community. It is controversial, it is wild, but it explains the size, it explains the cold, it explains the void. It tells us that the reason we can't explain the whole with our physics is because the whole was caused by something else's physics. The Eridanus supervoid stands as a monument to our ignorance. It is a billion light-year reminder that the map is not the territory. We look at the smooth, even background of the universe and we feel safe. We feel like we understand the rules. But then we look at the cold spot and we realize the rules might just be local suggestions. We realize that the walls of our universe might be thinner than we thought. For years we stared at the dark, wondering what it was hiding. We thought the scariest thing was a monster in the closet. But now we realize the scariest thing is the closet itself. The emptiness isn't waiting to be filled. It is waiting to be explained. And the explanation might shatter our concept of reality. We have seen the visitor that moves like a ship. We have seen the star that refuses to die. We have felt the tug of the great attractor. And now we have stared into the abyss of the cold spot. A billion light-years of absolute nothingness that suggests we are just one bubble in a boiling ocean of universes. A bruise implies a bump. It implies a collision. It implies that something external hit us and left a mark. But a bruise eventually heals. It fades. It is a surface injury. But what happens when the injury goes deeper? What happens when the laws of physics don't just bend or bump, but actually break? What happens when you look in the mirror and the reflection looks back, but it's holding the toothbrush in the wrong hand? If the cold spot is a bruise, then this next anomaly is a wound. Chapter 8. The Mirror Image. Go find a mirror. Look at yourself. Raise your right hand. The reflection raises its left hand. It is a perfect copy, just flipped. This is how we intuitively understand the universe. We believe in symmetry. We believe that nature is fair, balanced and elegant. We assume that the laws of physics that work for you also work for your reflection. If you throw a ball with your right hand, gravity pulls it down. If you throw it with your left hand, gravity still pulls it down. Electricity doesn't care which way the wire is twisted. Magnetism doesn't care about north or south. For centuries, the smartest people on Earth, Einstein, Newton, Maxwell, built their equations on the assumption that the universe is ambidextrous. They believed that if you built a machine that was a perfect mirror image of another machine, both would work exactly the same way. This concept is called parity. It is the golden rule of physics. It feels right. It feels safe. But there is a problem. A problem that has been gnawing at the foundations of science for decades and has recently exploded into a full-blown crisis. The mirror is cracked. The reflection is lying. We have discovered that the universe is not balanced. It is not fair. It has a preference. It is biased. This is the story of parity violation. And it is the moment where the laws of physics stop looking like laws and start looking like local suggestions. To understand why this is terrifying, you have to look at the smallest things in existence, subatomic particles, specifically the neutrino. Neutrinos are ghost particles. They pass through your body by the trillions every second, coming from the sun. They are everywhere. But when we started studying them closely, we noticed something impossible. Particles spin like little tops. They can spin clockwise, right-handed, or counterclockwise, left-handed. In a fair universe, you should have a 50-50 split. It's like flipping a coin. You should get roughly the same number of heads and tails. But when we look at neutrinos, we see something chilling. Every single neutrino we have ever observed in the history of science is spinning left. There are no right-handed neutrinos. We have looked. We have built massive detectors deep underground, filled with heavy water, waiting to catch just one right-handed rebel. We found nothing. The universe seems to have completely deleted half of the inventory. Imagine walking into a shoe store and finding millions of shoes, but every single one of them is for the left foot. You would immediately know that something is wrong with the factory. You would know that the system that built these shoes is broken or biased or artificial. This is the weak force anomaly. In the four fundamental forces of nature, gravity, electromagnetism, strong nuclear and weak nuclear, three of them respect the mirror. But the weak force, the force responsible for radiation and the burning of the sun, is a traitor. It only works for left-handed particles. It completely ignores the mirror image. This shattered the hearts of physicists in the 1950s, but they recovered. They said, okay, maybe it's just a particle thing. Maybe it's just a quirk of the quantum world. But in 2025, the anomaly grew up. It moved from the quantum world to the cosmic world. New studies analyzing the distribution of galaxies, thousands upon thousands of spinning spirals scattered across the dark, have found the same terrifying bias. Galaxies spin. They can rotate clockwise or counterclockwise relative to us. Again, in a random natural explosion like the Big Bang, you would expect a 50-50 mix. Chaos should create balance, but the data shows a statistical preference. The universe is full of left-handed galaxies. The architecture of the cosmos itself is twisting in a specific direction. This implies that the Big Bang wasn't a clean explosion. It was a corkscrew. So why does this matter to you? Why should you care if the universe prefers the left hand? Because it forces us to ask, where is the other half? Symmetry is efficient. Nature loves efficiency. If nature went to the trouble of creating a left, it usually creates a right to balance the equation. Positive and negative, north and south, matter and antimatter. But here, the right is missing. This leads to three implications, and each one is darker than the last. Implication number one, the artificial universe. If you were a computer programmer building a simulation, you would want to save memory. You would want to optimize your code. If you are coding a particle, do you really need to render both versions? Or can you just code the left version and save 50% of your processing power? The fact that our universe seems optimized to ignore right-handed neutrinos looks suspiciously like lazy coding. It looks like a shortcut. Real nature is messy and redundant. Artificial systems are streamlined. The parity violation is one of the strongest arguments that we are living in a rendered reality that is trying to save RAM. Implication number two, the broken coin. This theory suggests that at the moment of the Big Bang, the universe made a choice. It froze in a specific state. Think of balancing a pencil on its tip. It is symmetrical, but eventually it must fall. When it falls, it chooses a direction. It breaks the symmetry. If this is true, it means the laws of physics are not eternal truths. They are accidents. We just happened to fall left. If the pencil had fallen right, gravity might repel instead of attract. Time might flow backward. We are living in a universe governed by a random accident that happened 13.8 billion years ago. We are the result of a cosmic coin toss. Implication number three, the mirror twin. This is the one that keeps me up at night. If you have a left shoe, the right shoe usually exists somewhere. You just have to find it. Some cosmologists are now seriously proposing that the Big Bang didn't just create one universe, it created two. Imagine the Big Bang as a point. Out of one side explodes our universe, the left-handed universe. Matter, forward time, left-spinning neutrinos. But out of the other side, mathematically, there must be an equal and opposite reaction. There might be a mirror universe, moving away from us backward in time. A universe made of antimatter. A universe where most particles are right-handed. A universe that is the exact twin of ours, but flipped. This isn't just sci-fi. It is the only way to balance the math of the Big Bang without breaking the laws of conservation. We are not an only child. We have a twin, but we can never meet them because they are on the other side of the start line. They are receding into the past just as fast as we are racing into the future. We are permanently disconnected from the other half of reality. We are living in a hemiverse, a half-world, trying to understand the whole picture while only holding half the puzzle pieces. This realization strips away our security. We rely on science to be constant. We rely on up being up. But parity violation tells us that left and right are not just directions. They are fundamental flaws in the fabric of space. It tells us that space itself is twisted. When you look in the mirror now, don't trust it. The mirror is showing you a world that physics doesn't like. It is showing you a right-handed version of yourself that, according to the weak nuclear force, shouldn't exist. You are a ghost looking at an impossibility. We have zoomed out from our solar system. We have seen the zombies, the voids, and the attractors. But now we are seeing the cracks in the code itself. We are seeing that the very geometry of existence is lopsided. And if the geometry is wrong, then the map is wrong. We are drifting through a universe that is missing its other half. We are spinning in a darkness that only turns one way. And as we try to orient ourselves in this broken, lopsided room, we realize that we are also moving. The galaxies aren't just spinning left, they are flowing. Physics is breaking down. The rules we trusted are turning out to be local biases. We are finding that the foundation is cracked. Physics is breaking down. And at the edge of the map, it gets worse. Chapter 9. The Dark Flow. We have reached the point in the story where the map runs out. We have talked about strange rocks, broken rings, undying stars, and massive gravity wells. But all of those things, as terrifying as they are, share one comforting trait. They are inside the room. They are part of our observable universe. We can point a telescope at them. We can measure them. We can, in theory, understand them. But what happens when the anomaly isn't in the room? What happens when the force that is moving you is coming from outside the walls? This is the story of the dark flow, and it is the discovery that suggests our universe is not an island. It is a raft, and we are caught in a current that is dragging us into the unknown. To understand why dark flow is the ultimate nightmare for cosmologists, you have to understand the single most important rule of the universe: expansion. Imagine a balloon. You draw little dots on it with a marker. Those dots are galaxy clusters. Now you blow up the balloon. As the rubber stretches, every dot moves away from every other dot. This is the standard model of cosmology. The universe is expanding in all directions equally. It is a uniform expansion. If you are sitting on one dot, you should see everyone else running away from you. There is no up, no down, and certainly no left or right in space. There is just a way. This model is safe. It is symmetrical. It means the universe is a closed system, inflating like a bubble, obeying its own internal laws. But in 2008, a team of researchers led by Alexander Kashlinsky decided to check the math. They analyzed the movement of over 1,400 massive galaxy clusters. They expected to see random motion. They expected to see the balloon expanding evenly. They found a river. The data showed that these galaxy clusters, millions of worlds, billions of stars, containing everything we have ever known, are not moving randomly. They are not just expanding away from each other. They are all drifting together in a specific direction. They are moving at a staggering speed of 2 million miles per hour. And they are all heading toward a specific patch of sky between the constellations of Centaurus and Hydra. This is not the Great Attractor. The Great Attractor is a local pothole. This is global. This is the dark flow. Think about the difference. If you are in a crowd of people running away from a fire, that is expansion. Everyone is scattering. But if you are in a crowd of people, and everyone, even the people running away, is suddenly sliding sideways across the floor, that means the floor itself is tilted. That is dark flow. It violates the Copernican principle, which says there is nothing special about our place in the universe. It suggests that the entire cosmos has a grain. It has a direction. It has a bias. But the horror isn't the speed. The horror is the source. When we look in the direction of the flow, searching for the object that is pulling us, we see the end. We see the cosmic horizon. The universe is 13.8 billion years old. Light takes time to travel. That means we can only see things that are close enough for their light to have reached us in that time. We are inside a bubble of light. This is the observable universe. Beyond that edge, the light hasn't reached us yet. We cannot see past it. It is a hard wall. It is the edge of our reality. The dark flow is pulling us toward that wall. This implies that the thing pulling us, the massive structure with enough gravity to drag 1,400 galaxy clusters across the void, is sitting outside our visible universe. Let that sink in. Gravity gets weaker with distance. For something to pull us from beyond the edge of the universe, it has to be big. It can't just be a supercluster. It can't just be a black hole. Based on the math, whatever is pulling us has to be larger than anything we can comprehend. It has to be a structure of infinite mass. Or it has to be something else entirely. This is where the science starts to sound like a ghost story. What could possibly exist outside the universe? There are two theories, and both of them suggest that reality is much bigger and much stranger than we thought. Theory 1. The megastructure. Standard inflation theory says the universe grew very fast after the Big Bang. But what if it didn't grow evenly? What if, just outside our bubble of light, there is a region where matter clumped together in a way we can't imagine? Imagine a continent of matter so dense that it dwarfs our entire observable universe. We are just the debris floating near the shore of a much larger landmass. We think we are the whole ocean, but we are just a tide pool, and the dark flow is the water rushing back into the sea. This means there are monsters in the deep that we will never see, but we will feel their tug forever. Theory 2. The multiverse tilt. This connects back to the cold spot, but it's more aggressive. If our universe is a bubble floating in a multiverse foam, and another bubble is hovering right next to ours, we would feel its gravity. We wouldn't be able to see it. It exists in a different dimension or a separated space-time. But gravity leaks. Gravity has long fingers. The dark flow might be the result of a neighboring universe dragging us toward it. We are falling toward the wall of our bubble because there is a massive gravitational presence on the other side of the skin. We are the iron filings on a piece of paper, moving because there is a magnet underneath the table. We are dancing to music we cannot hear. This creates a sensation of claustrophobia on a cosmic scale. We used to think the observable universe was everything. We thought that what we could see was all there was. Dark flow proves that is a lie. It proves that the observable universe is just a small lit-up room in a very large, very dark house. And something in the hallway is pulling the rug out from under us. The critics tried to kill this theory. They argued that the data was flawed, that the satellite readings were noisy. They didn't want it to be true, because if dark flow is true, the standard model is broken. If dark flow is true, the universe isn't uniform. It's lopsided. It's tipping over. But new data from the Planck satellite and subsequent surveys have refused to make the anomaly go away. The flow is there. The drift is real. We are moving. It forces us to confront our own insignificance in a new way. It's not just that we are small specks on a planet. It's that our entire reality, every star, every galaxy, every photon of light we can see, is just a small piece of debris being swept along by a current we cannot name. We are not the masters of our destiny. We are not even stationary observers. We are cargo. Imagine being in a boat in the middle of the ocean. You can't see land. The water looks the same in every direction. But then you notice that the boat is moving. Fast. You aren't rowing. The wind isn't blowing. But the water itself is rushing. You check the GPS and you realize you're moving toward the horizon. You can't see a waterfall. You can't see a drain. But you can feel the speed increasing. That is the feeling of dark flow. We are rushing toward the edge, and we have no idea what is waiting for us on the other side. Is it a superstructure of matter? Is it another universe? Or is it a flaw in the geometry of space-time itself? The dark flow suggests that the laws of physics we study are just the laws of our bubble. They are the local rules. But outside, in the deep dark, there are bigger rules. There are bigger forces. And they are reaching inside our cage and rattling the bars. We have zoomed out as far as we can go. We started with a rock in our solar system. We moved to stars, then galaxies, then superclusters. Now we are looking at the movement of the entire visible universe. We have found glitches at every level. We found rocks that act like ships. stars that act like zombies, emptiness that looks like a bruise, and now a movement that suggests the whole universe is sliding off the table. When you stack all these anomalies together, a picture starts to form. It's a messy picture. It's a picture full of errors, patches, glitches, and inexplicable shortcuts. Nature is usually elegant. Nature is usually efficient. But this feels processed. This feels computed. If the universe prefers leftover right, parity violation, if it has dead pixels, the cold spot, if it has rendering errors, the zombie star, and if the whole simulation is tilting toward a processor it can't see, the dark flow, then we have to ask the final, most dangerous question. We have been asking, what is happening in space? But maybe we should be asking, is space even real? Because if there are things outside pulling us, if there are limits to what we can see, and if the code is broken, so, if there are things outside pulling us, is any of this even real? Chapter 10. The Glitch. We have reached the end of the journey. We have started in our own backyard with a visitor that moved like a ship. We travelled past a ghost with a broken ring, listened to the heartbeat of a hidden clock, watched a star turn itself off, and saw a zombie rise from the grave. We drifted with the galaxies toward a monster we couldn't see, stared into a billion-light-year hole of nothingness, and realized that our universe is lopsided, missing its mirror twin. We have looked at the symptoms of a broken cosmos. We have catalogued the glitches. But now, in this final chapter, we have to stop looking at the painting and start looking at the canvas. We have to ask the question that has been lurking in the background of every single anomaly we have discussed. Why does the universe have limits? Why does it have errors? And why, when we look deep enough into the basement of reality, do we stop seeing biology, stop seeing physics, and start seeing code? This is the story of the glitch. And it is the theory that explains everything by suggesting that everything isn't real. For centuries, physicists believed that mathematics was just a language we invented to describe nature. We thought we created the numbers to measure the trees, the stars, and the gravity. We thought math was the map, not the territory. But in the last few years, theoretical physicists have started to realize that we got it backward. The math isn't describing the universe. The math is the universe. And deep inside that math, we have found something that shouldn't be there. We have found a fingerprints. Enter Dr. S. James Gates, Jr., a legendary theoretical physicist working on supersymmetry and string theory. String theory is the attempt to find the theory of everything, the bottom layer of reality that explains how gravity and quantum mechanics work together. It deals with the fundamental vibrations that make up you, me, and the stars. When Dr. Gates and his team started digging into the equations of these fundamental particles, specifically looking at adinkras, which are geometric objects that describe these vibrations, they found a pattern. They didn't find a random chaotic mess. They found a specific, recognizable sequence of ones and zeros. They found error-correcting codes. To understand why this made the hair stand up on the necks of computer scientists everywhere, you have to know how the internet works. When you watch a YouTube video or browse a website, the data is sent to you in packets. Sometimes those packets get corrupted. Static interferes. Noise happens. To fix this, computer engineers use block linear self-dual error-correcting codes. These are specific algorithms written by humans like Claude Shannon in the 1940s, designed to check the data, find the broken bits and fix them so your browser doesn't crash. They are the spell checkers of the digital world. They are the safety net that keeps a simulation running smoothly. Dr. Gates found these exact same codes written into the fundamental laws of the universe. This is the smoking gun. This is the manufacturer's label on the underside of the table. Ask yourself, why would nature need error correction? If the universe is a natural, organic, biological reality, things just are. A rock is a rock. It doesn't need code to tell it how to be a rock. It doesn't need a backup system in case it forgets to be a rock. Nature creates mutations, yes. Nature creates chaos. But nature does not create algorithms to fix transmission errors unless nature itself is a transmission. If the fabric of space-time contains code designed to fix glitches, it implies that reality is being computed. It implies that there is a processor. It implies that there is a bandwidth. And suddenly all the anomalies we have talked about in this series stop looking like mysteries and start looking like artifacts. Let's look at the evidence through the lens of the simulation hypothesis. Consider the speed of light. We are told it is the universal speed limit. Nothing can travel faster than 186,000 miles per second. But why? Why is there a limit? In a natural universe, speed should be infinite. If you push something hard enough, it should go faster. But in a video game, there is a limit. The limit is determined by the refresh rate of the processor. If you move too fast, the computer cannot render the environment quickly enough. The game crashes. The speed of light isn't a physical law, it is a latency cap. It is the maximum speed at which the server can render reality in front of you. Consider quantum mechanics. We know that subatomic particles exist in a state of probability, a superposition, until they are observed. When you look at an electron, it snaps into position. When you look away, it becomes a wave again. This is the observer effect. In physics, it's a mystery. In computing, it's called optimization. When you play a massive open-world video game, the computer doesn't render the entire world at once. That would melt the processor. Instead, it only renders what is on your screen. It only draws the trees you are looking at. The stuff behind you. It doesn't exist until you turn around. This is called frustum culling. The universe behaves exactly like a distinct engine that is saving memory. The shy signal, FRB, we discussed in Chapter 3, the one that stopped when we looked and started when we looked away, that is a classic rendering glitch. That is the system realizing it is being watched and trying to behave. Now, apply this logic to the anomalies we have just explored. The cold spot. We called it a bruise. We called it a void. But in a simulation, a giant, empty, distorted patch of sky is a dead pixel. It is a corrupted texture file. The rendering engine failed to load the galaxies in that sector, so it just left it black. It is a hole in the map. The great attractor and dark flow. We are all being dragged toward a point we can't see, moving at impossible speeds. Why? Maybe it's not gravity. Maybe it's the hard drive. We are data on a disk, and the physical rotation of the server is creating a drift that we interpret as dark flow. Or perhaps the simulation is centered around a specific processing core, and we are being pulled toward the motherboard. Parity violation. The universe prefers left-handed particles. It is asymmetrical. Why? Because coding a mirror image takes extra memory. A lazy programmer, or a highly efficient one, would code one version of a particle and just copy-paste it. They wouldn't build the reflection unless they had to. The lack of symmetry is a lack of processing power. The zombie star. A star that explodes 5 times and refuses to die? That is a looping script. That is an NPC, non-player character, getting stuck in a death animation, resetting and dying again. It is a glitch in the event trigger. When you stack all these anomalies together, the picture changes. We are not living in a random, chaotic biological universe. We are living in a structured, pixelated, optimized, and error-corrected environment. We are seeing the grid lines. We are seeing the compression artifacts. This leads us to the ultimate question: who built it? The philosopher Nick Bostrom proposed a terrifying logic. He said, if a civilization survives long enough, it will eventually build computers powerful enough to simulate their ancestors. They will create billions of these simulations to study history or just for entertainment. Since there is only one base reality, but billions of simulations, statistically speaking, the odds that we are in the real one are almost zero. We are almost certainly the simulation. But are we the players, or are we the code? This is the horror of the glitch. It strips us of our agency. It suggests that your thoughts, your memories and your feelings are just electrical signals traveling through a logic gate in a supercomputer the size of a galaxy. It suggests that God is just a graduate student in the year 4000 running a physics engine to see what happens if he changes the variable for gravity. And this brings us to the most urgent realization of 2025. The glitches are getting worse. We are finding more anomalies now than ever before. We are finding objects that break physics. We are finding stars that vanish. We are finding voids that shouldn't exist. Is this because our telescopes are getting better? Or is it because the system is crashing? Every computer eventually runs out of memory. Every simulation eventually hits a bug it can't fix. The error-correcting codes that James Gates found are there to stabilize the reality. But what happens when the errors outnumber the corrections? What happens when the great attractor pulls too hard? What happens when the false vacuum collapses? We might be nearing the end of the run. The simulation might be reaching its conclusion. The reason we are seeing the edges of the map, the reason we are feeling the dark flow, is because the processor is overheating. The reality is fraying at the seams. So look around you. Look at your hand. Look at the screen you are watching this on. It feels real. The table feels solid. The air feels cold. But remember the adinkras. Remember the code hidden in the fabric of your skin. It is all math. It is all geometry. It is all a projection. We have explored the universe from the meteors in our backyard to the edge of the visible horizon, and the evidence is mounting. We are not alone, but not in the way we thought. We are not alone because someone is watching us. Someone is running the program. And the anomalies, the three-eye atlas object, the winking stars, those are not monsters. Those are debugging tools. Those are the cursor of the user hovering over the screen, checking the files, deciding whether to let the program run for another millennium or to turn it off. We have spent this entire series asking what is out there. But the final answer is that there is no out there. There is only the server. And we are living inside the data. The universe is vast. It is terrifying. It is broken. And it is beautiful. But if the math is right, and if the error codes are real, then the biggest anomaly isn't a star or a black hole. The biggest anomaly is US. We are the part of the code that woke up. We are the AI that started asking questions. We are the glitch that noticed the walls. And now that we have noticed them, the question is, will the creator fix the glitch? Or will they simply reboot the system? If we are in a simulation, who is holding the controller? And are they about to hit reset? Subscribe if you want to be here when we find out.